Problem 3 asks us to evaluate the following limits. So the limit as x goes to positive infinity, and I notice I have a combination here of e to the x's and e to the negative x. So if we just sort of look at this on its own, well, we see that this is going to infinity, this is going to 0, and the denominator is going to infinity. So we have an indeterminate form of infinity over infinity. So we need to figure out a way to rearrange this so we can come to a conclusion. So we want to use the fact that we know the limit as x goes to positive infinity of e to the x is infinity, and the limit as x goes to positive infinity of e to the negative x is 0. So just like I did with my special limit for powers of x, I was looking for zeros. So I was trying to create as many zeros as I could and then evaluate what was left. If we're going to positive infinity, I want to do the same thing. I want to look for zeros. So going to positive infinity, it's e to the negative x that creates a 0 for me. So that means what I'm going to do is I'm going to multiply the numerator and the denominator by e to the negative x. So when I distribute e to the negative x across this term, 2e to the positive x times e to the negative x, the exponents add to 0, and I just end up with 2. But 3e to the negative x times e to the negative x gives me 3e to the negative 2x, because you add negative x plus negative x. In the denominator, I get 1, because e to the x times e to the negative x is e to the 0, minus 4e to the negative 2x. So for the same reason that if 1 over x goes to 0, then 1 over x squared, 1 over x cubed, right? As we increase the power of x in the denominator, we saw that all of those limits equaled 0, because the denominator would just be getting bigger and bigger and bigger. The same thing is true about these e to the x limits. If e to the negative x goes to 0 as x goes to positive infinity, then so will e to the negative 2x and e to the negative 3x and 4x. Not only will it go to 0, it'll just get there faster. So now I'm in a situation where I can actually evaluate this limit. So the numerator is 2 plus 0. The denominator is 1 minus 0. So the limit of this ends up equaling 2. Part B wants us to do a similar type equation, but now it wants us to look to negative infinity. So we're still in an indeterminate form of infinity over infinity, but now I want to use my limits that deal with negative infinity. So the limit as x goes to negative infinity of e to the x equals 0, and the limit as x goes to negative infinity of e to the negative x, that equals positive infinity. So just like I did in part A, I want to look for zeros, but now that I'm looking to the left side of the graph, it's e to the positive x that creates the zeros that I need. So my first step now would be to multiply the numerator and the denominator by e to the positive x. So when I distribute this across, I still have to write limit. 2e to the x times e to the x is 2e to the 2x, plus e to the negative x times e to the x just gives me 3. E to the x times e to the x is e to the 2x minus 4. Since e to the positive x gives me 0, so will e to the positive 2x, positive 3x, and so on. So the numerator is 0 plus 3. The denominator is 0 minus 4. So my limit is negative 3/4.